My name is Lucas Athanasopoulos, student number 244-76158.
My name is Kristian Tica, student number 244-76119. We'll be using my student number for the demonstration.
My name's Eric Kuok. My student number is 244-66474.
My name is Kyle Reyes. My student number is 13578620.
I will now share my screen. Yep.
All right.
So first, I'm just including some libraries and defining some variables. Our first function is the map function. Just maps the input range to the output range of the ADC to the server in that.
Our second timer is our second function is our ISR timer 0. And basically what it does is it controls an LED. When the ADC has a value of less than 115, the LED is permanently on. If the counter is greater than the ADC value, then the LED will toggle, and what that looks like is flashing. And if the counter value is less than the ADC value, then the counter will increase until it is greater than that.
This is just checking for a high in the USCRAO, USCR0A register, and then writing a bit to the UDR0 register. Bit inside that register. This is a loop iterating over the string to put them all together into the puts char UART function. This is initializing the ADC registers as well as mapping some of the values.
Our function ISR timer 2 is used to control the toggling LEDs. So how it works is basically it will read the state that is in based off the button press that is shown later on, and then if it is pressed, it will blink the certain LEDs. Our timer 2 is currently set to a frequency that is not 1 Hertz due to the limitations of timer 2 being an 8-bit timer.
Some registers being set. Timer 0, ADC, timer 1, timer 2, UART.
Yeah, so this is our state A. So it's reading the push button inputs. So for the button state part, it's reading whether the push button 1 is being pressed. If it is, it will be toggling LED 1, and then the other, if it isn't, it toggles the other LED. And when it receives a input from the other push button, it changes states.
We can also see in this state the server value changes as well. This prints the UART function or this string in the initial state, and this checks for a T input.
Missing from this code is the functionality of the LCD. Within the LCD, there are a few functions. It was the initializer two-way interface, which through the TWSR, TWBR, TWDR, TWCR, and port C registers, the two-way interface is initialized. The initialized LCD, which sets to line mode with font size, turns display off, clears the display, and then sets entry mode. The LCD light, which turns on the backlight. The put char TWI, which sends data to the I2C backpack, and the puts LCD, which sets a cursor position and sends a string of data from a sprintf function to the LCD board. Why we weren't able to get this code to work was because we were unsuccessful in turning the data from the sprintf function into data which was able to be put onto the LCD board in the form of text.
So we'll now run it, upload this code. So it's going to launch in the state A, which will be the serial monitor state. Give it a bit. It's now reading. If I change the serial monitor, the potentiometer, the reading will change. Also, when I press T, it will pause the input. Oh, sorry, I didn't need to click it. As you can see, the input is paused. I press it again, and then it goes back to sending the inputs. That's state 1. Now we just enter it manually into state 2 as we couldn't get the button to work. We upload this code. I'll now stop screen sharing to show my screen in a bigger. Spotlight me. You ready?
Yep.
Alright, as you can see, we have these two LEDs. One is blinking when it is not pressed. If I press it, the other one is on. Not pressed, the other one is on. Now, see this one, if we move it, the period is longer, and you saw the step-up servo motor as well change. Get that again. As you can see. As you can see, the period is shorter, sorry.